Well, here's an interesting one with multiple solutions, an IVP, that's an initial value problem with multiple solutions. So this is weird.
Shut up and start talking.
Okay, I'll start talking. So here's the equation. Y squared minus x squared times y prime is equal to 0 with initial condition y of 0 is 0. Well, the general solution, you'll just have to trust me about this one for now, is y equals x over 1 plus c times x, which looks innocent enough, but there is no way to solve for the c, because if we put in 0 for x and 0 for y, 0 goes in here, 0 goes in here, we got 0 equals 0, and no matter what c is, 0 does equal 0. Actually, it'd be 0 equals 0 over 1, darned if it doesn't. So you cannot solve c. Matter of fact, any c will work. If you put in 5 here, then you'd have 0 equals 0 over 1 plus 5 times 0. So it sure is. And this is kind of silly to go further than that, but they're nice to know, though, what was bad about this one with this particular initial condition, so that we have a general solution that would not allow us to find a unique particular solution. Okay, and it would be nice to know if there was such a way of doing that, and the answer is there is. So there really is a way to determine if the solution is unique.
I am so glad.
I'm glad that you are glad. So here's the story. If the region R, which is rectangular region in the xy plane, and x sub 0, y sub 0 is in the interior of R, that means it's not on the border. Sometimes you notate that R with a kind of R to the 0 power, but that means R without its border. And both f of xy and the partial of this f of xy with respect to y are continuous on the interior of R. Then there is an interval I centered at x sub 0 and a unique function y of x satisfying the first order differential equation dy dx equals f of xy with the initial condition y of x0 equals y0. Now, why was our example, this one, bad? Well, there's a reason, because if you went to solve this one for y prime equals y squared over x squared. So f of xy is y squared over x squared, and if you think about it, that is not continuous on any rectangle that would contain the line where x equals 0. In other words, the y-axis. So if we contain the y-axis, if our initial condition is on the y-axis, then we got some serious trouble. And that's what happens. The y of 0 equals 0 is on the y-axis because x equals 0. Actually, it's the origin, and that cannot be because of this part of our differential equation. All right? I hope you can see now why that one failed.
Nice work.
I'm glad you find it good.